Polly the Polynomial Penguin here, talking to you about factoring monomials from polynomials. Now here's a question. Where do penguins keep their money? In the snowbank! Wah, wah.
First thing we're going to talk about are prime numbers. Those are numbers whose only factors are itself and 1. So here is a list of the first few prime numbers, and it goes on forever. What you can see is that 2, there's no other numbers besides 1 and 2 that multiply together to make 2. 3, there's no other numbers besides 1 and 3. 5, there's no other numbers besides 1 and 5 that multiply together to make 5, and so on. Those are how you get prime numbers. Next vocabulary term are factor trees. Those are diagrams that show a number or monomial broken into its prime factors. This is also called prime factorization. What you're going to do is you're going to take a number like 40 and you're going to break it down into its prime factors. So I'm going to take 40, and you need to first think about two numbers that multiply together to make 40. You could pick 8 and 5. You could pick 2 and 20. I picked 4 and 10. So after you do that, I pick 4 and 10, you then go to each of those numbers. 4. What are two numbers that multiply together to make 4? And it can't be 4 and 1, because that would do no good. So we do 2 and 2. Now, are those prime numbers? Yeah, so that's where we stop. Then we go over to 10. What two numbers multiply together to make 10? Well, that would be 2 and 5. Are those prime numbers? Yes, so we can stop. And it's pretty cool because 2 times 2 times 2 times 5 gives you 40. That's why these are called the prime factors of 40, because they all multiply together to make 40. This 12, we break it up into two numbers that multiply together to make 12, so that would be 4 and 3. We then look, is 4 a prime number? No. So we break that into two numbers that multiply together to make 4, 2 and 2. Are those prime numbers? Yes, so we can stop. 3 is a prime number, that's why we didn't keep going, and you see that 2 times 2 times 3 gives you 12. That's why those are the prime factors of 12. And then 26, we break up into 2 and 13. Those are both prime numbers, so we can stop, and you see 2 times 13 gives you 26. Now, the greatest common factor, or what we will refer to it as the GCF, is the highest number that divides exactly into two or more numbers. So in this case, we have 40 and 12, and we just showed how to break those two numbers into their prime factors. What you're going to do to figure out what the GCF is, you just look at which prime factors do these two numbers have in common. So the prime factors of 40 are 2, 2, 2, and 5. The prime factors of 12 are 2, 2, and 3. So what prime factors do these two numbers have in common? Well, that would be the 2 and the 2, right? They both have two 2's. So what we do to figure out what the GCF is, you just multiply whatever they have in common. So 2 times 2 gives you 4. Therefore, the GCF, or greatest common factor between 40 and 12, is 4. And we'll get into that more later on.
What kind of fish do penguins catch at night? Starfish! Wah, wah. Example time.
Now, example 1 says find the GCF of the given numbers. So here our two numbers are 15 and 75. Now we're going to do exactly what we just did. We're going to break each of these two numbers into their prime factors. And then we'll pick out which ones they have in common, multiply those together. That's the GCF. So we'll start with 15. Two numbers that multiply together to make 15 would be 3 and 5. So can you break either of these numbers into two numbers that multiply together to make those? No, these are prime numbers. That's why you stop there. Let's go to 75. What two numbers multiply together to make 75? Well, there's a bunch of different options here, but I'm going to pick 15 and 5. Now, can you think of two numbers that multiply together to make 15 that aren't just 15 and 1? Yes, that would be 3 and 5. What about 5? Can you break that up? No, those are prime numbers, and then 3 is also a prime number, so you can stop. Sweet. Now, to figure out what the GCF is, we go ahead and look. What prime factors do these two numbers have in common? Well, they have a 3 in common, and they have a 5 in common, meaning that their GCF, or greatest common factor, is going to be 3 times 5, which is 15. And you say the GCF of 15 and 75 is 15. And you look, you can always double check. Can 15 divide into 15 and 75? Yeah, it divides evenly into both of those numbers. Therefore, yes, it is the greatest common factor. Perfect. Part B, we have 8 and 9. So we're going to break each of these numbers into their prime factors. So we'll start with 8. What two numbers multiply together to make 8? Well, that would be 4 and 2. Now, 2 is already a prime number, so we can stop there. But 4 we can break up into 2 and 2. Sweet. Now we go over to 9. What two numbers multiply together to make 9? That would be 3 and 3. Can you break those up any further? No, those are prime numbers, so you stop. Next, we look for our GCF. So what prime factors do these two numbers have in common? They don't have anything in common. So if two numbers don't have any prime factors in common, there's one number that divides into every number. and that's 1. So we're going to say the GCF of 8 and 9 is 1. Anytime you have two numbers that you break down in their prime factors and they have no prime factors in common, the GCF is 1.
Where do penguins go to dance? At the snowball! You try.
Okay, doing the same thing. So we're going to break 16 and 24 down into their prime factors. So we start with 16. What two numbers multiply together make 16? Well, there's a couple options, but I'm going to pick 8 and 2. Once I've done this, I see that 2 is already a prime number. So that is going to stop this branch. But this branch, the 8, keeps going. What two numbers multiply together to make 8? That would be 4 and 2. Again, 2 is a prime factor, so that branch stops. But the 4, I know two numbers that multiply together to make 4. That would be 2 and 2. Now I'm all done with 16 because I have reached all prime numbers in each of my branches. So those stop. Let's go to 24. Two numbers that multiply together to make 24. There's a few different options here. I'm going to pick 12 and 2. 2 is a prime number, so that branch stops. The 12, though, breaks up into 6 and 2. You could have also done 3 and 4. That works as well. The 2, again, is a prime number, so that branch stops. But this one, the 6, breaks up into 3 and 2, because those multiply together to make 6. Now you've reached prime numbers in each of your branches, so you can stop. And we see that 2 times 2 times 2 times 2, that equals 16. 3 times 2 times 2 times 2 equals 24. Now to figure out what the GCF is, you just see what prime factors do these have in common. There's a 2, there's another 2, and there's another 2, which means that the greatest common factor between 16 and 24 would be 2 times 2 times 2, which is 8. So the GCF of 16 and 24 is 8. You can also check that. Does 8 divide evenly into 16 and 24? Yes, it does. Cool. 49 and 14. Let's go ahead and do that. 49 breaks up into 7 times 7, and 7 is a prime number. Therefore, you can stop with each of those. Sweet, that was easy. What about 14? 14 breaks up into 7 times 2. That was also very easy because each of those are also prime numbers. So what's the greatest common factor between 49 and 14? Well, they each share a 7. So 7 is going to be the GCF of 49 and 14. Now, does 7 divide evenly into 49 and 14? Yes, it does. So that checks out. Example 2 says find the GCF of the terms of each polynomial. So here we have a binomial, right? Two terms. And we need to figure out what is the GCF of these two terms. Well, to figure out the GCF of two terms in a binomial, trinomial, polynomial, it works the exact same way. We're going to take 4a to the 4th, and we're going to break it up into its prime factors. The first thing you do, anytime you have a number and a variable, right? A coefficient and a variable, we're going to break those up right away. So the first step, we're going to go 4 goes over here and a to the 4th goes over here because 4 times a to the 4th equals 4a to the 4th. Now with the number, if I want to break up 4 into its prime factors, that's just 2 and 2 because 2 times 2 equals 4. Sweet. What about a to the 4th? How does that work? Well, a to the 4th actually is the same as a squared times a squared, right? Because if you multiply like bases, you add the exponents. So a to the 2nd times a to the 2nd, you add the exponents, you get a to the 4th. Now, can you break up these anymore? Well, yeah, we just said a to the 2nd times a to the 2nd equals a to the 4th. That would mean that a to the 1st times a to the 1st would equal a to the 2nd. So I'm going to break up a squared into a times a, because a to the 1st times a to the 1st equals a to the 2nd. When you multiply like bases, you add the exponents. Sweet. Now, I can't break up a anymore, so that would be a prime factor. Done. Here, a squared, we just said, breaks up into a times a. Perfect. So we have completely broken down 4a to the 4th. Now let's go to 6a squared. So again, the first step, anytime you have a coefficient and a variable, we're going to break those up right away. Next, what we do is we break up 6. How does that break up? Well, what two numbers multiply together make 6? That's 3 and 2. Those are both prime numbers, so we can stop. Now, a squared, we said, breaks down into a times a. Awesome. Now we have completely broken down each of these two terms. So to find the GCF, we just see what prime factors or variables do they have in common. They have a 2 in common, and they have 2 a's. So to figure out what the GCF is, you just multiply those together. What's 2 times a times a? That's 2a squared. 2a squared is going to be the GCF of 4a to the 4th and 6a squared. And you can see that 2a squared actually divides evenly into each of those numbers. Perfect. You're done. For part B, we're doing the same thing. So here we're going to break down each of these into its prime factors and break down the variables all the way, see what they have in common. So we'll start with negative 12w squared. Anytime you have a coefficient and a variable, we want to break those up right away. We'll start with the negative 12. Now, anytime you have a negative number, I want you to think about taking those apart. So it's going to be, instead of negative 12, we're going to break that up into 12 times negative 1. Now, technically, negative 1 is not a prime number, but if each of these numbers end up having a negative 1 that you could take out, that could be part of your greatest common factor. So please just be aware anytime you have negative numbers, take out a negative 1. So here, we break negative 12 into 12 times negative 1. That stops that. Now here, 12, we can break that up into 6 and 2. Could have picked a couple different things, but we picked 6 and 2. Now the 2 is a prime number, but 6 breaks down further into 3 times 2. Okay, so it looks like we have broken the negative 12 all the way down into its prime factors. What about w squared? Well, we said w squared, just like a squared, is going to break down into w times w. Sweet, this one's all done. Let's go to negative 15w. Anytime you have a coefficient and a variable, we break those up. That's first. The w doesn't have a w squared, it's just w, so that's done. Negative 15 though, we said anytime you have a negative number, take out that negative 1 right away. So it's going to be 15 times negative 1. Sweet. The negative 1, we stop there, but the 15, we can keep going. What two numbers multiply together make 15? That would be 3 and 5. So we now have prime numbers all the way across the board here and here. That means that we can check for our greatest common factor. So what prime factors do they have in common? Well, they have a 3. They also have that negative 1 in common, which means the GCF is going to be negative, and they have a w in common. So to figure out the GCF, 3 times negative 1 times w gives you negative 3w. So that's going to be the greatest common factor between negative 12w squared and negative 15w.
What do penguins call their kids? Children! You try.
Okay, doing the same thing here. So we're going to break up each of these into its prime factors. So we'll start with negative 25f squared. We said anytime we have a coefficient and a variable, we want to break those up right away. So it's going to be negative 25 times f squared. Now the negative 25, that's a negative number, and we want to get rid of that negative right away. So we change this, or factor it, into 25 times negative 1. Now the negative 1, we're done with that, but 25, two numbers that multiply together make 25, that would actually be 5 and 5. Each of those are prime numbers, so we can stop. The f squared, we can now break down into f times f, because f to the first times f to the first gives you f to the second. When you multiply like bases, you add the exponents. Sweet, that one's all done. What about negative 15f? Anytime you have a coefficient and a variable, we break those up right away. The f is just f to the first, so that's done. But the negative 15, we can break up more. Since it's a negative number, we want to break that into 15 times negative 1. And then we can break up the 15 into 3 times 5. Awesome. Now, we have broken these all the way down. What do they have in common? Well, they have a 5, they have a negative 1, and they have a f. If we multiply those together, we get our GCF. 5 times negative 1 times f is negative 5f. So that would be the GCF of these two terms. For part B, we're going to do the same thing. So we start with d cubed. Let's break up d cubed. Now, anytime you have a coefficient and a variable, we break that up first. And the good news is that 2 is already a prime number, so that's done. D cubed, though, how do we break that up? Well, two things that multiply together make d cubed would be d squared and d to the first, right? Because if you multiply like bases, you add the exponent. So 2 plus 1 would give you that 3. So the d to the first, that one's done. But the d squared, we can break that up more into d times d. Now we have broken this all the way down. 2 times d times d times d equals 2d cubed. Now what about negative 20d? Well, let's break it up. First, the number and the variable, we separate those. Those multiply together to make this. The d is already done, but the negative 20 we can break up more. Now, anytime it's negative, we said we want to take out that negative 1 first, and then we can break up the 20. Two numbers that multiply together to make 20 would be 4 and 5. And then 4 breaks down more into 2 times 2, but the 5 is already a prime factor, so you're done. Now, in order to figure out what the GCF is, you just look at what prime factors or variables do these two things have in common. So we look, they both have a 2, and then they have a d as well. That looks like it. So we would say that the greatest common factor between 2d cubed and negative 20d would be 2d. Now example 3 says factor each polynomial. So we're going to now factor this polynomial. Now how does that work? Well, it works the exact same way. So let me show you. We're going to start by taking each of these terms and breaking them down. So we start with 6a squared. How do I break that up? Well, again, anytime you have a coefficient and a variable, we break those up first. Now 6 we know can break down into 3 times 2, and those are prime numbers, so you're done. The a squared we break up into a times a. We have broken 6a squared all the way down, so we go over to negative 10a. How do we break that down? Well, we separate the coefficient and the variable first. Negative 10, we break up into 10 times negative 1, and then we break up 10 into 5 times 2. This is broken all the way down now as well. So we look for our GCF. What is the greatest common factor between these two terms? It looks like they both have a 2 and an a in common. So it looks like 2a is going to be the greatest common factor. So what we do is we take 2a and we're going to put it on the outside of a set of parentheses. Now, what goes in the parentheses? Well, it's what's ever that's left over from each of these terms. So we look at our first term. What's left over? What factors are left over? Well, it would be a 3 and an a. So that means 3a is going to go first. Now, what goes next? Well, what's left? 5 and a negative 1. So 5 times negative 1 is negative 5. So we write 3a, then minus 5. Now I want you to notice, factoring with a GCF like this is just reverse distributing. I took this and then factored out the GCF. And if I want to check my answer, all I have to do is take this 2a and distribute it to the 3a and the negative 5. And what I should get is what I started out with. So if you distribute this, yeah, you end up getting this exactly. And that's how you know you did this right. So let's try again. We're going to factor out our GCF. So we look at each of these terms separately. Here, we're going to break this up. Now this actually has a coefficient and 2 different variables. So we're going to break this up into 3 separate things: 17, x, and y to the 4th. The good news is that 17 is a prime number. X is already done, but y to the 4th we can break up into y squared times y squared, and each of those we can break up into y to the 1st times y to the 1st. Now that's completely broken up. So let's go to 51x squared y cubed. Again, this has a coefficient and 2 different variables, so we want to break those up separately. So it's going to be 51x squared y to the 3rd. 51 we actually can break up into 17 times 3. X squared breaks up into x times x. Y to the 3rd, these ones are always tricky. Remember, it's just y squared times y to the 1st. And the y squared we can then break up into y times y. If you get good at this, you'll be able to just take y cubed and break it up into y times y times y. That works the exact same way. Now, we look for a greatest common factor. So what do both of these have in common? Well, 17, an x, and they both have 1, 2, 3 y's. Therefore, the greatest common factor would be 17 times x times y times y times y, which is 17xy cubed. We're going to put that on the outside of a set of parentheses. What goes in those parentheses? Well, what's left from each of those terms? So in the first term, the only thing that's left is a y. So we put that. There you go. In the second term, what's left? Well, a 3 and an x. So what's 3 times x? That's 3x. Since it's positive 3x, we write y plus 3x. And you're done. That's how that works. Again, you can always check your answer by taking this and distributing it. You should end up with your original problem.
What do you call it when a snowman has a temper tantrum? A meltdown! Wah, wah, wah. You try.
Okay, let's do this again. So we factor out a GCF, which means we need to figure out what the GCF is between each of these numbers. So we start with our first one, negative 18r squared. We break that first up into negative 18 and r squared, right? We got to break up the coefficient and the variable first. Negative 18, we take out that negative 1 first, and then we can break up 18 further into 9 times 2. And the 9 we can break up into 3 times 3. Awesome. That one's completely broken up. The r squared now we break up into r times r. Now we move on to the negative 30r cubed. So how do we do that? Well, we first break that into the coefficient and the variable. Then the negative 30 we can break up into 30 and negative 1. The 30 we can then break up what 2 numbers multiply together to make 30. That would be 6 and 5. And then the 5 is prime factor, so that's done. But the 6, we can break up further into 3 times 2. Now, this is completely broken up. Let's go to the r cubed. How do I break that up? Well, again, you could go r times r times r, or you could say that it's r squared times r to the 1st, and then the r squared you can break up into r times r. Either way, we're now done. We've broken up each of these, so let's figure out what the GCF is. So what do they have in common? They have a 3, they have a 2, and they have a negative 1. What about the r's? They have 2 r's. So if I were to multiply those things together, 3 times 2 times negative 1 times r is negative 6r squared. That's going to be our greatest common factor. So we put that on the outside of a set of parentheses. On the inside, we put whatever's left from each of those terms. So the first term, the only thing that's left is a 3, so that goes here. The only thing that's left from this term is a 5 and an r. So we multiply those together, you get 5r. Since that's positive, you write plus 5r here, and you're done. Here, we go ahead and do the same thing. Let's first break up 13mn squared. Now, again, we have a coefficient and 2 separate variables. So we're gonna break this up 3 times. So it's gonna be 13m and n squared. The good news is that 13 and m, those are both done, but the n squared, we can break up further into n times n. The 26m squared n squared, we're gonna have to break up again 3 times. The 26 we know breaks up into 13 times 2. Those are both prime, so we're done with those. The m squared breaks up into n times m, and the n squared breaks up into n times n. Now, since these are both completely broken up, we look, what is the greatest common factor? Well, they both have a 13, they both have an m, they both have an n, and an n. So if we multiply all those together, you end up getting 13mn squared. So that's your greatest common factor. That goes on the outside of a set of parentheses. And what goes inside? Well, what's left from each term? Well, in the first term, there's nothing left. So don't just leave it blank. If there's nothing left, what you write in the parentheses is a 1. Now, what goes in the other spot? Well, what's left? A 2 and an m. 2 times m is 2m. Since it's positive, we're going to write the 1 plus our 2m. Now again, you could distribute this and you should get the exact same thing you started with. Example 4, we now have a trinomial that we're going to do this with. It works the exact same way, except we just have 3 terms now. So we have to break up each of those. So let's start with 33d cubed. We start by breaking up our coefficient and our variable. The 33, we know breaks up into 3 times 11. The d cubed, we have done this a couple times now. You could write d times d times d, or you could just write d squared times d, and then break up your d squared into d times d. Now the 66d squared, we break up the coefficient and the variable first. The 66, we're going to break up into 6 times 11. And then the 11 is a prime number, so that stops. But the 6, we break up more into 3 times 2. Okay, that's done. The d squared, we know to break up into d times d now. Lastly, we go to our negative 11d, and we break that up, the negative 11 and the d first. Since it's negative 11, right, we want to make it 11 and negative 1. That way negative 1 is one of our factors. And then, wow, that's done. That was easy. Now we look for our greatest common factor. What do each of the 3 terms have in common? All 3 terms have to have it in common. Well, they all have an 11. They all have a d. Is that it? Yeah, that looks like it. So 11 times d is 11d. That's your greatest common factor. That is what goes on the outside of a set of parentheses. What goes inside? Well, we break it up by each term. So first term, what's left? What factors are left? That's a 3, a d, and a d. So what's 3 times d times d? That's 3d squared. So that goes first in the parentheses. The next term, what's left? 3, 2, and d. So what's 3 times 2 times d? That's 6d. So since it's positive, we write 3d squared plus 6d. And then lastly, we just have a negative 1. That's the only thing that's left. So at the end, we write minus 1. And you're done. Again, you could always check your work by distributing it to each term, and you should get what you started with.
What did the serious penguin always say? It's no joke. You try.
Okay, same thing here. So we start with our first term. This has a coefficient and 2 variables, so we break this up 3 times, 14, x cubed, and y. The 14 we can break up into 7 and 2. The x cubed, again, you can break up into x times x times x, or you could go x squared times x, and then break up the x squared into x times x. The 63 x squared y squared, we break that up 3 times, 63 x squared y squared. The 63 we know to break up into 9 and 7, and our 9 we can break that up into 3 times 3. The x squared, we now know to do this, it's just x times x, and the y squared we know is y times y. Perfect. Lastly, the negative 7xy cubed, we break that up, negative 7xy cubed. The negative 7 we can break up into 7 times negative 1 because it's negative, right? We got to take that out. And, well, that's done. The y cubed we break up, you could break it up y times y, or y squared times y. Then the y squared breaks up into y times y. Now we have broken up each of these into their factors. What do? We need to factor out the GCF. So what is the GCF? What do each of our 3 terms have in common? They have a 7, they have an x, they have a y. And that looks like it, right? So 7 times x times y is 7xy. That's going to go on the outside of our set of parentheses. Now what goes on the inside? Well, that depends. What's left for each term? The factors that are left for our first term are 2x and x. So 2 times x, that's 2x squared. Boom, that goes first. Next, what's left here? a 3, an x, and a y. So what's 3 times x times y? That's 9xy. So since that's positive, we write plus 9xy here. And then lastly, we have a -1, a y, and a y. So -1 times y is negative y squared. So since that's negative, we write minus y squared, and you're done. Again, check your answer if you want by distributing it to each of these terms. You should get exactly what you started with.